Hello, today I will talk about functional event sourcing. There is functional in the, but you will see it's not very complicated. So I'm working at a company called The Age in the hospitality tech, and you can follow me on Twitter, thinkbeforecoding, or follow my blog that I update approximately once a year, thinkbeforecoding.com. As this will be a live coded session, so I promise to show you the code. We will write the code live during here. The goal of the presentation is to be totally unimpressive. Okay, so the idea is that nothing scary will happen here. Everything will be simple, and the goal is that you can then do it at home without taking too much risk. So let's start with what we are doing in most of our system and how we run them. The thing is that when we want to write some code, we receive some commands that ask for change, and so from somewhere we get some commands. I will just write this way. And we want things to happen, but if it reacted the same way all the time, it would get quite boring. So the result of the command will depend on something. And this something is previous history, or what we usually call states. So what we do is that we'll say, okay, I want to decide. And when you ask me to do this, the command, and I mean that state, okay, this is what happened. But usually we take some decision and we mutate the state directly, and then we don't know in an expressive way in the system what was the decision. We just see the effect of the decision, the change. But we never expressed the actual decision correctly. So here what we will do is that we will express the meaning of the change as events. So we will return events like that. And we'll try to do it in a pure functional way. By that, I mean just that the values of the events depend only on the values that you put, you input. Okay, so I have a command and a state. These are both immutable, pure values. And based on that, I do some domain stuff to take some decision, and my result will just be to return events, like being values also, one or several or zero. And once I've done that, I will be able to use those events to compute my new state. So for this, I will evolve state, so we will just create an evolve function that takes an event and a state. And the idea is that when this happens, I'm in this state, here is my new state. This is also a pure function, which means that for a given event on given state, I always get the same result state, okay? This is pure values, input values, output values. Well, I can then just wire things this way, and we get our system running. So, I read it back. You ask me to do something, and I'm in some state. I decide that this is what happens. Okay, I get it, just values. I take these values, I take my current state, I give it to the evolve function that gives my new state. I'm ready to take the next command and start again, okay? This is the simplest way to write event sourcing, your domain as event sourcing. Just write two functions, one that decides, one that evolves, okay? We'll just do that now. And so, our sample domain will be very simple. It will be a light bulb, okay, that we can switch on or off. If it's already on and we switch on again, it does nothing, and just that, okay? We'll discuss about the choice of the sample afterward. So let's start. I will start to define a command type, okay? And my command for now, I don't know what it does, so I will just say do something, okay? And I will also create an event type for my output that says something happened. And maybe I will need some state, but it will be just initial state, like that, okay? So here what I do is that I create 3 types that have totally uninteresting values. Okay, but now they exist. So each one have a single value, which is the thing on the right. Okay? So command is just do something, and event is just something happen, and state is just initial state. Now I can write, based on this type, this decision function. This is this one, decide. And decide will take, as we said, a command like that, and state. And we'll have to return some events as an event list. Maybe I will just go back to 150 so that everything fits on screen. Yes, this is the longest line, I think, in the whole presentation. And there is a really simple implementation of that already, which is you ask me to do something when I'm in this state, which is always initial state, and what's happened is an empty list of events, so nothing happens, okay? This is a valid domain that just decide to do nothing when something is required to do that we don't know what, okay? Okay, it just follows the pattern we said. And then we have an evolution function, which takes a state on the command, on the event, okay, event like that, and that will return a new state. And what is the simplest way to implement this function? It's just to return the input state. So it says, when I'm in this state and something happens, I just stay in the same state, okay? So this is also a totally valid evolution function that just always stays the same. Let's start from here. And now what we will try to do is to actually write some domain code, run it, and test it. So it will be easy. We have 2 commands. It's a light bulb, so let's write our commands, which are switch on and switch off. So in F#, it's a you can consider it like being a kind of enum or something, but we can add more values inside. But I think you see the pattern. So the events will be switched on and switched off. And for the state, I don't know. I will just create a late initial state value whose value will be initial state for now, and that's good. Okay, so we want to write tests for this domain, and how we can express it. It will be actually quite easy. What we'll do is that we will write tests like that. We'll say, given those past events happened before, when we try to do this command, this is the output events we expect. Okay? So for that, we will create a test framework. Okay, I put some codes. L codes on it because it will be actually quite simple. The first one is this arrow operators that I use an operator in F# because operators are infixed, so I can put the events that have happened before and the command after. You will see it will be really easy. So I have events on the left and a command on the right. And what I do is I will say, okay, you give me some events. I have an initial state. I have an evolution function. I will take my initial state, the first event, give them to the evolve function, get a new state, take the next event, do it again, get the new state, and in the end, by repeating this operation, I end up with my current state. Okay? I don't talk about replay. I talk about just doing a computation. Okay? It's not a replay, it's a computation. It's just, on this operation has a name, it's called fold. Okay, aggregate in some other language, but globally the idea is here. So I will take my events and I will pass it to the list.fold function, and fold is expecting the aggregation function that takes the previous value and the new value in the list and outputting the value. So it's actually what our evolve function do. Evolve like that, and it ask for an initial value to feed the function at the when the first element in the list, and we have a value for that. It's initial state. So when I do that, I take my events, the evolve, the initial state, and the result is my current state. Great. So I can take this current state and pass it to my decide function, because the decide function needs a state. So I will give my this state to the decide function, and the decide function also expects my command, so I will just give my command. And the result of this operation is to take an event list on the left, a command on the right, and it will return an event list. Okay? So now I just have to check that the event list is the one I expect, and so I will just say equal to equal, double equal to equal. This is just for alignment. You don't need that, but it's nicer to read after that. So I just say equal is equal to equal. Okay, well, I wrote it. And then we can do things like, okay, when nothing happened before and you ask me to switch on, the result is switched on. Okay? The thing is that for now, I can run the code on the right, and it's false. Why? I didn't implement it, of course. So my first try is this one. I can just say, okay, when you ask me to do something, I say I switched on, and now my test will pass. It will be fantastic, but I'm just cheating a bit. No, it's not. We switched on. Okay, it did not compile. Like that. And now, yeah, it runs. Cool. We have our first test. It's great. Second test will be a bit more difficult, because now we will try to say that if we already switched on before, switched on, like that, and we try to switch on again, nothing happens. So this test will not pass, because for now we are always saying switch on. So the thing is that we have to remember that we have already been switched on. So something we can do is that instead of having an initial state as an only value, we'll say we are either on or off. We will try to remember about that. And the thing is that if the event we just get is switched on, my state is now on. Okay? So my new state is that if I've been switched on, I'm on, and my decision will be that we start in the off state, and now I can decide based on what's happening, match command with, and I also take my state. If I'm off and the command is switch on, the result is switch on. Other condition, just nothing happened. So that's, for now I don't need anything more to implement for my test to run, so we just limit to that. And run the first test, it's passing. Run the second test, it's passing also. Cool, we have two tests. Now, of course, we will try what's happening when we switch off, and it will be quickly done. Like if nothing happened and I try to switch off, nothing should happen. And the next one, I will implement both at the same time, because you understand the pattern. If we switch on and then off, it will switched on. It should be switched off. Okay? That, yes. And to implement it, it will be easy. We just say that if we are on and you want to switch off, it's switched off like that. And here, so you can see that it's complaining that I didn't handle all the case, so I will just add until it's working. Switch off, we're off. Cool. And we can run all the tests. Like this one is working, this one is working, the next one is working, and the next one is working. Great. We have our light bulb. The problem is that now the business arrives and says, the problem is that after 3 use, the light bulb is just broken. Okay? So we have to change the system so that after 3 switch on, switch off, switch on, it will break. So they say, yeah, we have a new case where switch on, switched off, switch on, oops, switched off, switched on, switched off, like that, and then switch on, and here I expect it broke. It doesn't exist yet. But okay, well, just add this event to the possibilities. Broke. So doing that, I just extended my domain, and the test is not passing. How will we handle that? The problem is that my state currently is not able to actually remember how many times it was switched on and off, so I will have to make an aggressive refactoring of my state to remember that. Usually when you start to do things like that, you have to go back to your tests and change them because they will break. Here, as you can see, the state never appear in my test. So I can change my state as I want, and the test will just remain the same. Okay? So let's do that. So now my state can be either working with value inside that is saying when it's working, it's on or off with the value inside. So I just will use working type for that, or it can also be not working, in which case it's broken, like that. Whoops, broken, and then the working state. I will have a status which is on or off. Oops, no, I will just retype it. On or off, and the working type will be status, which will be a status, and remaining uses, which will be a number, like that. Okay, so. From there, of course, I have to change my initial state because my initial state now will be working with the status off and remaining use of free. From here, my code is not compiling anymore because I'm using the old state, but you can see that nothing changed in my test. That's cool because my refactoring won't affect at all my tests. So what should we do? If the light is working and the remaining, and if its status is on and the remaining uses is 0, the result will be that it will break. It will be broke, like that. Okay? So we are off. Excuse me. You're off. We are asked to switch on, but there is 0 remaining used. So we just say, okay, it broke. But if we're working, oops, and the status is off and not 0 remaining uses, we just switch on. And if we are working and status is on and we just switch off, we switch off. And in any other cases, remaining, yeah, I'm missing a thing like that. No, we just, yeah, okay, it's great. Working status off and the command is switch on, like that. Okay, it should work, and here I just wrote not okay. So now I take all the decision as I should. So when there is no remaining use, it will break. When you in the other situation, we just do the same. And when it's broken, we always end up in this case, this one which does nothing. Okay. And now we just have to update our state based on what happened before. So if we're switched on, so if we just broke, this is the event, our state is now broken. Okay? If the event is switched on, the new state will have to be built based on the previous one to remove the value. So we'll do state, and here say whatever my state. If I just broke, I'm broken. And here what we will say is that we will we were in a working state. So in a working state with state which was S, and here. So in this case, what we will do is create a new working state, which will working, that will have a status of on, and the same value for when we switch on. Yes, we have to remove one for the remaining uses. So remaining uses equal s dot remaining uses minus 1. We'll just move on another line so you can read. Okay, and this one also there. Cool. And if I was in a working state S and I've been switched off, my new state is still working, but with the status off, and the remaining use is the same. I can just write as with like that. Okay? And any other thing that happen, I don't care. I just return my state like that. Now we will see if our tests are still passing. So up, here, 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 it's still good. Here, and now this one is passing also. Okay, so what you see is that I write my test in a totally behavior-driven way. So my state never happens, never appear in my test. So I can choose whatever structure I want for my state because it will not appear in the test. I can rewrite it. I have new insights. There are new action. I can change it. Okay. So it's very interesting, even for a simple part of your system, to write it this way. Just split decision and evolution, and you can already use this kind of testing. Okay, this is cool. The thing is that after that, you've heard a lot of terrific and freaky stories about event sourcing and how it's hard to run in production. So I will show you how you can run event sourcing this domain and in a totally not freaky way. So I will do that. Let's start. Okay. And this, I will create a command handler. My command handler will say, okay, I have a mutable state, which is initial state. Okay, and here I will just put a publish like that. And what I do is I will return a function that takes a command, and will do that. So I have a state, the initial, which is a state variable, which initially is the initial state. You give me a command, and what I will do is I will just get events from calling my decision function with my command on my state. And now that I have these events, I can just fault them on my state to get a new state. So let new state equal list.fold. So as you've seen, it's not very impressive functional code for now. It's just like standard code, but with the F# syntax. It's all okay. You can write it in any language. Maybe just the unions are a bit more tricky in some language, but you all have a mechanism to do things like that, inheritance and all that. So just continue. Here I'll use the fold with the eval function with my state. So I take my current state, my eval function, I take my new events, apply them all on my state to get a new state. So it's a new value, and what I do is just I put it in my state. Okay, and then for each event in the return events, I call my publish function with the event, and here I am. I can run it. So let's run that. Let light equal start. And what I will do, my publisher will be actually a printer that print the event value. Okay, so the event will be a data structure, and printf %a is just making a pretty printing of this on my console. So start like that. Okay. So here. So my light now is something that takes command and do something. So this is unit is like void in most languages. So it's just something that I can call with a command and will do something. So let's do it. Light switch on. So I have to pass commands. So switch on for instance. And when I call it, oh, it switched on. Let's do it again. Oh, it's doing nothing. Right. This is exactly what we intended. And now I can switch it off. So I run the line. It switched off. If I do it again, nothing happened. This is also, I can do it again, nothing happens. Cool. It's exactly what we tested in our test. So it's normal. I can switch off, switch on. So it switched on. I can switch off. Just emitted a switched off event. And starting again, great. And oh, it broke. Cool. And now I can do whatever I want. Nothing will happen anymore. I've been running event sourcing here. Okay. So it's not very impressive. Because running this aggregate is this code. Now you will tell me, yeah, but okay, Jeremy, this was a dumb model with a small light bulb. Yeah, but actually I don't care what is inside this function. You can take your hospitality take or student loans thing or financial market. If your function has the signature, if you have those two functions with the signature common state events and event state event state, you can just put them here and here, put your initial state, and just run the exact same code for your domain. Okay? And you don't have to use an event store to run it. You can just run like that. Okay, true. If I restart my session here, I lose my state. But for some systems, short life event, part of aggregates, it's totally fine, okay? Even the rest of the code can totally not be implemented with event sourcing. I can have one aggregate running like that, and all the rest running the usual way in the same process. You don't have to make everything event sourcing, just this light bulb is event sourced. The rest, no. Same process, the amount of code to run it, that. Okay, but I don't persist, so I'm cheating a bit. So let's add persistence to the mix, okay? So the thing is that usually when we say event sourcing and persistence, people think, okay, event store. Okay, I will be a bit heretic here. I will just take a small snip here. This code is just serialization for my state, okay? So we have a deserialization function that take a string and will. So my format will be this one. I will go next line. So the thing is that when it's on, it will be on with the number of remaining, off with the number of remaining, or broken, and this is just the deserializer in the other direction. Of course, usually you will use something like JSON serializer or something, but you understand the idea. This is just that. Okay, this is the serializer. Take state, return. And now, what I will do, ta-dam, I will write something that most people just didn't thought about. Let's start. This is a new version, publish. And this time I will not keep the state in memory, but we will persist. How will we do that? It will be very simple. I will say, okay, I know I also need something. Yeah, you will see. I create a command that takes a command. A function that takes a command. And the first things I will do is to load my current state. We'll do store dot load, and I will just need the name. Okay. I will load my state from somewhere. We will write the store.load function just after that. I will load my state. Once I have my state, next thing I will do is that I will use it with my decide function to get events. Okay? So decide with my command and my state. I get events. Now I can get my new state by just list fold evolve state and events. So I have my new state, and what I will do, I will do store dot save name new state, and for event in events do publish event. Cool. So here store load and store save doesn't exist yet, but the thing is that actually this is the same code, but what I do is I load the state, do the thing, save the state. This is usually what you are just doing in most of your system. The only thing I did is that I split the decision part from the evolution part and run them. Load, save, load, save, load, save. Will tell me it's not event sourcing. Yeah, maybe, but I get all the benefits and I'm ready for the next move. So let's just write the actual store. Module, store, and the store will be easy. So let load name, cool. I will need open system.io, and if file.exists name, then match file.readAllLines name with. So I just read all the lines. I will expect only one line in the file, so I will call it line. And if it's here, I will just deserialize it. So state.deserialize line. In other cases, I just have nothing to return, so I will return my initial state, and or break if you prefer. You see, and if there is no file, initial state also, because that's my first event, my first deserialized state. It's a state option, so I will return yes, none, and then. So in F# you have options, and options tell you if you have a value or not. So here I will say, okay, I could not load the state, so take care of it. And so here I will just say, okay, load, and if you have no state, option.default value, use the initial state like that. So up, I will just reformat it to fit on the screen. So here I have my load function that if it can find a file that contains the state, I load it, deserialize it, and return it. Okay, and to save, it's even easier. So let save name and state, and I will just say file.write all lines, and the path will be the name, and the value will be just one line with serialized state dot serialize of my state. Great. I have just a small thing to do before, or we cannot see the result here. Okay. And now I can run this. So to run this, we'll do almost the same thing that's there, but just with our new light like that. And what we do is that we'll do, no, it's not net state, it's start. Like that. And I will call it light 1. And still publish like that. So I will run all the code before to have it. And now I create my light, and when I switch on, it should do something, and I can verify it because now I have a file called light1 there that actually contains my current state. Yep. So I can also switch off, so you can see that it changed underneath. Okay. And if I reset my session, I lose all the state in memory, but it's not a problem because I will still recover the state from the storage. So it's switched on, switch off, switch on, and then at some point it will break. Yes, it's broken. Okay, it's not. Yeah, I know why it didn't. I have to put this line. This is just so that the current directory is my this directory. So I start my demo again because I just started another light which was not in the same directory. But here, okay, let's go. Check on, off. So you see one remaining used. I use it again, and now it's broken. Okay, so this is also the same code. So I add no change inside my domain to run it with persistence. The only change is this function to run it. Of course, maybe you don't want to use something like loading or saving from a file. But if you have any document database, just load, save, it's okay, it works, okay? You can even have a row in a SQL database and write read, it's okay, you can do that, it's totally okay. The next thing is that at some point you will want to actually save the value in the event emitted in the event store. So maybe you can do something like store.appendEvent here and save them, but still run it this way. If you have people in your team which are not comfortable with event sourcing, you still have the full event log, but you just read and write from the database. Yeah, you can do this. This is a good way to introduce event sourcing in your team without being scary. After that, yes, of course, you want to see the code when we use an actual event store. So let's do it. So we'll do another start like that. And a second like that, name and publish. And so this time what we will do is that there are two ways to do it. We can either reload all the events each time and to rebuild. So this way we don't keep anything in memory, but you will ensure the rebuild each time. Or you can also keep the state in memory, and so you will only have to load it at first. So you choose whatever you want. The structure of the code is just a bit different. You will move things, repeat or not, keep in memory or not, but it's not very difficult. So let state, which will be mutable, so we will keep it in memory. Mutable state equal, and here, what should I do to actually get my state? So to get my state, I will have to read all my events from the store. So I call them load. I will call them load state and save state here, because I will use load and save for events. It will be better. So I want to load my events. So okay, let's do that. So store dot load with my name, and I should get the full list of events that happen for this name. Okay, think your stream. When I have a list of events, I can build a state by doing always the same trick. List.fold with my evolve function and my initial state, and I get my current state. Cool. Then I say give me a command and I will do the thing. So what I will do is I will say, okay, let's events. My events will be the result of my decision function. Decide with my command and my current state. And after that, from here, I can just save my events. So store dot save name events. Right? But to be ready for if I don't want to keep state in memory, I can just do this one. Yep. So if I want to not keep state in memory, the easiest version is this one. Okay. So I load all the events for this name. I fold them. Oops, I remove the evolve initial state part. Yes, like that. So I fold them, I get my state, I decide, I get some events, I save the events. I'm done. I'm just publishing by calling the for each publish again at the end. Okay? Like that. Here, it's really easy. Let's run it. So I will just add a load and a save for my events. So for that, I have a small snippet to serialize and deserialize the event. As you can see, it's not rocket science. Just so switched on becomes switch on, switch off broke, and the other direction, nothing more. So my load, let load with a name, will say, okay, if file exists, then file reader lines, and what I will do is just sec map. So for each line in the file, I will just collect the result of my deserialization, event.deserialize. So deserialize is returning a list. So I will get lots of lists, and I will just put them as one after the other to get a single list. Why I use a list as a return for my serialization is because this way I can either return no event when I don't know what the event is, or I can return one when I have one. But sometimes if you want to split an event in two because your design was not good, you can return a list with two events and will output from your deserialization as two events while you had only one in the source store. And after that, that's all. And if the file doesn't exist, I just return an empty list. Yeah, I have to convert my sequence to a list, so sec.toList to be consistent. Okay, cool. And the save, name and events is not more complicated. It's just a file dot happen all lines, and I have my name, and I will save what? Just list dot map of my serializer, so event.serialize with my events. Okay, so I take each event, I get a string, I get a list, I happen all the lines at the end. Okay, I have my store. It would work, okay? So let's do it again. So this time, yeah, it should compile and run. So let's run light 2. Like that. So here, my light 2 does nothing, but when I start it, first thing, what? Oh, yeah, sorry. True that. Yeah, I think, okay, let's change it to light 3, it will be better, and up to not reuse the same file, it will be faster this way. So I create it, and I switch it on, and you can see that my file is here, and I have my switch on inside, so just see what happens when we run the rest. And now, switch on, nothing happened, but switch off, it adds like that, and this is my current implementation of the event store for the demo purpose. But for some of your system, it's just enough. Okay, so and the next one broke, and from there nothing happens. Okay, so this is a system that is event source with persistence. That's really cool. I can keep the state in memory this way. It's very not complicated, because this way, instead of rebuilding each time and rereading the full thing, I can just say, okay, like I did before, I keep here the state in memory, and what I will do is save the events and just save in my current state the result of the fold. Evolve state and events. So here, I load my state once at the beginning, and after that, so if something already happened when I start, I just reload everything and I'm ready, okay? If nothing happened before, I get an empty list. I start from the initial state. What I do is that when I receive the first command, I take this command in my current state, get some events, I save these emitted events to my event store, compute my new state, publish, and I'm ready to take the next command. This is the code I run in production. Maybe the only things you will do, there will be two more things and I will have time to show you. But the thing is that maybe save will be async, and in most languages it's not very complicated to add, okay? And the other thing is that here my system is running. I can change this by putting a SQL database, putting a document database. I can do a lot of things. I can use an event store. But the only thing that is not possible here is that if a command happens on another computer, I will not know it and work on the previous state I computed myself, and not the one that has been changed somewhere else. Okay, so to avoid that, what we do is that instead of doing only that, we will add something. When we load, we will also return the number of events. So I will do something like let lines equal this lines. Here I will say let events equal, and I will just return my version, which will be the number of lines, so lines dot length and the actual events. And if the file is empty, I will return 0, and like that. And before doing the append, what I will check is that the file didn't change, so I will be given an expected version. Okay, and I will just do something like if file, so let lines all if file dot exists, then file with all lines, and I return the length. Okay, else 0, and I will just say if lines different from expected version, then fail. This is just throwing an exception, wrong expected version, which means that something else happened somewhere else and you're not ready for that yet. So we'll do this here, but I will explain you. And the thing is that if it works correctly, what we will do is to return the new length, which will be actually lines plus events length. Okay, so I just add, because I can compute it without reloading the file. Okay, so I return that. So my save function now has a slightly different signature. It says give me a name and the version that you expect to work on, and the list of events you want to save. But if it's not the current state of your actual history, it will just fail. Okay, you cannot return an exception, but return either a success value or failure value, of course, but we will start with that. So the first thing we'll do is that we'll get a version and a state S from, and if there is nothing in the store, we will just return 0 with the initial state. So yep, I have to fix that. Yes. No, it's not the right. Okay, sorry, I changed the wrong thing. It was more like here. So check. I take. Oop. So okay. Let me 2 seconds to load things like that. So let version V and S. So I get the version on the state from the loading the event store, on the events, I mean. And then my state will be just for my events like that, and I will also create a let mutable version, which will have the initial version. And each time I will store, and I will save the version here, and I will put my current version there for my state, and I'm ready. So here the small change I did is that when I load, I take my current version, okay? And at the moment I will save, I will check that I'm still in this version before actually saving. If it's not the case, I will get an exception, and what you will just do is do something like try, catch the exception with, and here what you can do is just, you have the current version, there were a few more events. What you can do is just say, can you load the few events that have happened after my last action that happened somewhere, and you can just fold these few events on your current state and get the new state and just rerun the thing. Okay. So I have 5 minutes, so maybe I can. Yeah, you've seen the idea. You want me to write the code? It's just 5 or 6 more lines of code. Write it. Okay, sure. So let mutable saved. So it's totally not very functional code, as you can see. You'll false while not saved. Do. And I will do that. And the thing is that if I cannot, so the only thing I need to add is to load, but not from the start. Okay, so I say version, and the only thing I will do is to actually skip sec.skip version. So when you ask me to start from version X, I just keep the first line, okay? An event store will do it for you. You will not get all the data and skip, but here this is exactly the same thing that will happen. And so what I do here is that I will say, okay, if I could not save the state because of that, I can just retry by doing my new version, my new let, so v and events equal store dot load name and my current version. So here I will get the new last version and the few events at the end, and so my new version is v, and my new state is list.fold evolve my current state with the new events. Okay, these ones. And I can say that I didn't succeed, but here, if I reach here, I can say saved true. And now this code, which is fitting on this screen in 150%, is able to run event sourcing with keeping state in memory, but still doing correctly when some events have happened on another box. So if you have load balancer or failover or things like that, you don't care. You can keep state in memory. If it happens that something happens somewhere else, we'll just reload and be ready to retry the action. Okay? If you have a lot of events, you will want to add snapshotting to that, and I have 2 minutes to explain where I add snapshot in that. The thing is that instead of load from 0 there, I can just say, okay, if a snapshot exists, I take the state on the version, and I use this version for my load. My initial state will not be initial state, but the state of the snapshot. Okay, and the version to start with will be the version in the snapshot. I can load from there. And after that, after a large number of events have been written, I just take my state, my current version, and save them as the next snapshot. If no snapshot, I start from 0 with initial state. If I have a snapshot, I use it. Okay? A good thing to do is also to add a hash of your evolution function inside your snapshot. So what you say is you take the IL or bytecode or whatever you can, or the source code, and you create a hash at a startup in your process. You just keep the value of the hash, and you put it in the snapshot. Okay. If you load the snapshot and the hash match, you can just use it. If it doesn't match, just start from 0 initial state, and you're good. So after that, you can just deploy. Okay. Yes. Sorry. Yes. I just need to move this one. Yeah. If some people took a picture, take this version. It will be better. Sure. Or it will try again and again and all that. Of course. Of course. The thing is that so as you can see here, I have my save and load, and the next thing I will just do is to take this implementation. Okay, that is the same as my store, but using the event store. The only thing I will do is that if it's not good, or instead of returning some, I will throw an exception to be compatible with what I've done. Throw fail with wrong version. Okay, and so that it compiles, I just have to load the NuGet package for the thing, like that. So I load, I load my event store, like that. So the version of the event store, as you can see, has exactly the same signature. So you give the start number, you give the name of the stream, and it will load. So it uses the read stream event forward async to get a slice, and will just deserialize the event. And the save is just taking the expected version on the event and calling it's just converting to the event store serial objects, and call a conditional append to stream to do the thing. And now I can have a drop-in replacement to actually save and load from the event store. Like that. So I just load this code. Yes, seems to be working. I will also load this code. Something is not working. What is it? Yep. The value is not a function and cannot be applied. What is my problem here? Yep. No, I have something wrong with the rest of the code. I will try to fix it quickly. Check. Yeah, that's the demo effect. Probably something around here. And then the event store. And this code, no, I have a problem somewhere here, and I don't. Yes? It's a red in the middle, but I didn't run it, so it should not be a problem, but it has a problem here with... Yes, sure, it was not defined. Thank you. Okay, I run it. So, here we go. Oh, I have another problem. So, yeah, I changed something before, and it's not compatible anymore. Just reset, run. I will try to redo it here. Yup. State, it's working, and the event store, there. Okay, it's starting the event store, and then this code, this is my function. It's kind of working, and now let's run it. and switch on, and what we will see is that in my event store that is just here, I have my light 3, which is here. So I can, yeah, it will work. So where is my Visual Studio? Ah, it's full screen. I have to remove the full screen thing, like that, to put it on the left. And so let me show you. So as you see, it has already been switched on and off, and now I can switch on, off, and you can see it in the event store live. And now it broke, so nothing happened anymore. Okay, so I could just drop the event store inside. If you don't need this piece of infrastructure in your system, files, document store are totally fine. But as long as your domain has the right structure, because as you've seen, we've done a lot of different architectural change. At the beginning, it was running only in memory. Then it was persisted. Then it was persisted but with events, and then it was persisted with events and concurrency resolution and all that. And we never touched one line in the domain. Okay, the domain doesn't have to care about that. So once you write your domain as these two functions, you can run it any way I just showed, and you can add more after that with more async or more and the rest. But the thing is that if you want to change your infrastructure, you change just the infrastructure code, which will be the same for all your aggregates that run this way. And if you need to change your domain, it will never change the infrastructure code that runs it, which actually is most of the time you spend with accidental complexity in your system while dealing with domain code. So with that, yeah. Start small, run it, and as your needs grow, adapt by putting just a few lines of code. The full implementation, so we did something like 3 or 4 implementation. All the code is in the file. We have less than 300 lines of code, so I hope that you're not impressed. Thank you.